Good morning, students. Take two again. But we're looking to apply some of what we learned on right triangle trigonometry to some real world problems. And to do that, we're specifically going to look at problems involving angles of elevation and angles of depression. So let's get started. And I hope you'll recall some of the things we talked about before as we go through these problems. Okay? So when we're doing these problems, these applications, and I grabbed these steps from another slideshow, and I did not tag the source, so these are not mine. I didn't write these out. Same with the image, but you're going to want to start by drawing a diagram. To solve these problems, I can't solve these without drawing them out. Okay, I'm going to have to draw out what they're telling me and seeing what side measures are given, what angle measures are given, and then what trig ratios are appropriate to solve the problem at hand. You're also going to want to label your sides. So any given information on the problem, you always label on your diagram. You're going to want to identify the correct trig ratio, depending on what angle is given, depending on what side measures are given. You're going to put that information from the question into a ratio. And these are some simple steps. If the unknown is on top, you're going to end up multiplying. If the unknown is on the bottom, you'll end up dividing. And if your unknown is the angle, you're going to have to use your inverse trig ratio to solve. And I do want to point out that all problems are taken from a worksheet that I found online. This is the web address for it. I don't think you'll be copying that down, but anyways, that's the source. But if you did want to know where I got these problems, you could Google some of this text and probably locate it online. But let's get started with our first problem. It says Brian's kite is flying above a field at the end of 65 meters of string. If the angle of elevation to the kite measures 70 degrees, how high is the kite above Brian's head? So as we start this problem, first I want you to look at what type of problem we're dealing with, and that is angle of elevation. And an angle of elevation is measured from the horizontal upwards. Okay, angles of elevation and depression are always measured from the horizontal, some horizontal line, and elevation is measured above that horizontal line, depression is measured below the horizontal line. So as we go through, we're going to draw these out. So we want to start out by drawing the ground, okay? So I'm just going to come down here and I'm going to draw my ground right here, and I like to draw my ground like this. And what else are they telling us on this problem? His kite is flying above a field at the end of 65 meters of string. So somewhere up here we are going to have, and I'm just going to assume, yeah, it says how high is the kite above Brian's head, but they didn't tell us how tall Brian is, okay? So we're going to assume he is right on the ground, okay, just for sake of this, since they didn't actually give us a height. We could assume a height, but again, I'm not worried about that because in the end, we want to know how high the kite is above his head. So I think this will be fine the way we're doing this. So we're going to draw the kite. You know, why not? You know, I don't know about y'all. Have y'all ever flown kites? We used to make kites every year. You know? You always had to have a tail to help stabilize it. You tie cloth onto the end of it and whatnot. And it says it measures 70 degrees. The angle of elevation is measured above the horizontal. So you're going to label that. You're told that this is 65 meters of kite string. And then you're asked to find how high is the kite above Brian's head. Now assume his head is this point down here, right here. Then we're going to say the height above his head would be a straight up distance. And so I hope you're seeing that with that being the case, if we label this H, then we have formed a right triangle, okay? So if I look at this right triangle, then I need to understand that the sides that are given me with respect to the 70-degree angle would be the opposite side and the hypotenuse, okay? And remember our SOHCAHTOA? You guys remember that from the last lesson? Well, which of these trig ratios, sine, cosine, or tangent, uses the opposite side and the hypotenuse? Well, that's going to be this one, our sine. So we're going to set up a sine function. So the sine of this 70-degree angle is equal to our opposite side, which is h. So we're going to put in h over our hypotenuse is 65. And that is meters. So our height is also going to be in meters. So right now, and I hope I don't work all the way down and overlap with my little inset video there, but we'll see. I'm going to put this over 1, and we have a proportion, so we can cross multiply. So 1 times h is equal to 65 meters times the sine of 70 degrees. So our h is equal to what? Well, we have to punch this on our calculator, and I'm just going to go to my calculator on my cell phone, and let's see if I can locate it. And I do believe if you turn your phone sideways, yes, we have some trig functions, and yes, I want to make sure I'm in degree mode. So I am, and we're going to say 65 times the sine of 70. And that is equal to 61.08. So we get 61.08 meters. And that is our answer. So this kite is flying 61 meters above the head of Brian. Okay? So see, it's not so bad. Start with a diagram. Draw everything out. Label everything you're given on the problem. And then look and see what you have with respect to a trig function and pick the most appropriate trig ratio, set up the problem, and solve. Okay? So even though these are real world problems, once you set them up, they're exactly what we did last time. Okay? All right, our second problem is an airplane problem. It says from an airplane at an altitude of 1,200 meters, the angle of depression, okay, so we're looking at an angle of depression now. So unlike the last one, the angle of elevation was measured above the horizontal. This is going to be measured below the horizontal. And that's going to be measured down to a building on the ground, and it measures 28 degrees. They want to find the distance from the plane to the building, okay? So we're going to set this up. We're going to draw it out just like before. I'm going to draw my ground, okay? So there's the ground. I'm going to draw my building here. Yeah. All right. And once I have my building, I think we can draw my ground. All right. And you can't have a building without a door. And I might even want some windows on my building. Okay. These aren't very good windows, but it's okay if it looks cartoonish. And we need a airplane. Okay, so let's draw this out if we can draw an airplane up here. So there's our airplane. And I guess we can make this a propeller plane. And we need a horizontal here, so we're going to make that blue. Okay, so we're going from here to here, and that's going to be our horizontal, because again our angle of elevation is measured from that, and we're going to measure from there down to our building. So here's our building, and we were told that this is an angle of what? 28 degrees. And we're trying to find the distance from the plane to the building. Now, we're going to assume that they want the ground distance, okay? So we're going to draw a height of this triangle. So we're going to draw this part because we're told information about that as well. We're told it's flying 1,200 meters above the ground. That's its altitude, which means we have a right triangle formed here. And the distance from the plane to the building, I agree, guys. When I see these problems, it is ambiguous. Okay, are they talking about the direct distance along the hypotenuse, or are they talking about ground distance? Well, we're going to assume that they want the ground distance, and I'm going to call that D. And I want you to recall, think back to your Math 2 days when you did parallel lines, because obviously the ground, which we're assuming is flat, is horizontal to this horizontal trajectory of the plane. And if that's the case, then this distance here, the diagonal from the plane to the building, is a transversal cut across two parallel lines, which means this 28 degree angle of depression is the same as an angle of elevation measured from the building to the plane. Okay, so that's the interesting thing about angles of depression and elevation. Depending on which point you're at, one could be seen as an angle of depression and the other is seen as an angle of elevation, looking back at the other object. So anyways, now we have our right triangle, we have it labeled, and we want to see what trig ratio would be appropriate to use on this problem. So in this case, if I have 28 degree angle here, with respect to that, you're given the opposite side, and do you recall this one? It's not the hypotenuse, that's across from the right angle, so this must be the adjacent side. And if you recall, the correct trig function for using opposite and adjacent sides would be our tangent function. So we're going to write tangent of 28 degrees is equal to our opposite side, which is 1,200 meters, divided by our adjacent side, which is our D. Now do you see why when the D is on the bottom, you're going to end up dividing by the trig function? So if we multiply this, cross multiply, we get D times the tangent of 28 degrees is equal to 1 times 1,200 meters. And then we're going to divide out tangent of 28 on both sides. And this tangent cancels and leaves you with D equal to, and again you want to pull out your calculator and find out what that is equal to. So I'm going to turn it sideways. We're still in degree mode. Always double check that, guys. 1,200 divided by 2810 news announcement is equal to, and I get a distance of 2,256.87. Now guys, ladies and gentlemen, let's say I'm on a multiple choice test and I have assumed that this is the distance they're talking about, but I don't see the answer choice. Then I would assume that, hey, maybe they did mean the hypotenuse distance. And all I would have to do is do a quick Pythagorean theorem on this, and we could determine the other distance. And I'm not going to take time to do that. But again, to me, this problem is ambiguous, and sometimes these problems actually mention ground distance. But again, I'm just not sure. I don't like to assume stuff on this, so if it doesn't say, I might go ahead and say it's ground distance. And if I, on a multiple choice test, then I'm going to say, hey, if I don't see my answer and I feel good about my math, that I've done it correctly, then I'll do a Pythagorean theorem to find out the other distance. And that'll be fine. All right, our third problem, again, from a point on the ground 12 feet from the base of a flagpole, the angle of elevation of the top of the pole measures 53 degrees. How tall is the flagpole? So again, this is one you're going to want to draw out. So I'm going to pick a color. We'll do some green grass here. How about that? That can be our ground. So we're going to do our ground as green. Okay. And we want a flagpole. Okay. So we're going to draw our flagpole. Yay. And it's going to be a flagpole without a little thing on top, but I can't find it. So we're going to draw our flag. Can we draw a flag? We want to draw a flag. And this is not a flagpole if it doesn't have a flag on it. So here we go. I'm going to draw me some little thing and kind of leave some little white stars there. That's okay. Don't ask me to get the number of stripes correct. I'm just kind of ad-libbing right now. Okay. It's going to be whatever it is. But it's going to look like a flag. Okay. Kind of weird flag, but that's okay. Guys, I don't know about you, but doing these problems, I love drawing my diagrams. I just like drawing, so it's fun. That's the fun part of it, so enjoy it. So from a point on the ground 12 feet from the base of the flagpole. Okay. So we're going over here 12 feet from the base. Okay. So we'll say 12 feet right here. And they have an angle of elevation, okay, from this point up to the top of the flagpole. We have an angle of elevation of 53 degrees. And we know this forms a right angle. And they want to know how tall is the flagpole. Well, that would be the height h of the flagpole. So now we have our right triangle formed. We have our measures given on the problem labeled on our diagram. So now it's time to pick the trig ratio that applies to this problem. So again, we're looking at things with respect to the 53 degree angle given. And I want to know what side measures they gave me. And in this case, they've given me the opposite side. And right here, they've not given me the hypotenuse here, but they did give me the other side that I can reach out and touch. And remember, that would be the adjacent side. Okay? So once again, we're looking at which trig ratio has opposite and adjacent? Yes, we're looking at tangent. Okay? The tangent of 53 degrees is equal to the opposite side, which is our height of the flagpole, divided by 12 feet, which is the adjacent side. So if I Put this over 1. I have a proportion. I can cross multiply. 1 times h is h. And then I get 12 feet times tangent of 53 degrees. Okay? So again, we're going to go to our calculator. And I will say, guys, if you are on Desmos, you can certainly type in your trig functions there, but I will remind you, you must check and make sure you're in degree mode. Use the little tool icon in the upper right and double check at the bottom of the window that pops up that you are in degree mode. Okay, because you will get the wrong answer. Okay, so here we go. We're going to say 12 feet times 53 tan equals, and we end up with a height of 15.92 feet. Okay, and there you go, and that is your answer. So again, these are pretty straightforward. If you'll draw out the problem, do your diagram, form that right triangle, label all your measures, and then pick the appropriate trig ratio and then solve it. Okay? So let's move on to the next one. All right, for this one, we have a plane flying due east at 265 meters above sea level. The angles of depression of two ships sailing due east measure 35 degrees and 25 degrees. And they want to know how far apart are the ships. Whew. Man, what are we going to do on this one? Well, we got to draw it out first. Okay, so first of all, we have a plane. And we also have water. So I'm going to use blue for my water down here. Okay. I'm going to leave some workspace too. So there's my water. It's a little wavy looking. That's okay. It's water. And we have an airplane flying up here. Oh. There's some stuff back there too, buddy. Alright, so we have an airplane, and it is flying above 265 meters above. So we're going to say this is right here above the water. It's not quite straight down, but again, it's representative. 265 meters above sea level. And then we have two ships, okay? So we're going to say, and this is not going to be the scale, guys, but we're going to have two ships here. And we'll have some little smoke. And then we have another ship over here. It's almost out of the water. Oh no. So it's another ship. And we're looking at measuring, okay? So we're measuring from the airplane down at an angle of depression. So I should point out again our horizontal right here, because that will help us also. And we are measuring from that horizontal down to the first ship, okay? And then we're going down to the second ship. And this first angle of depression, I'll label that in red, I guess. So one of these is 35 degrees. And again, that makes this angle here what? 35 degrees. And the other one we'll label maybe this bright green. So this one is 25 degrees, which makes this angle 25 degrees. Okay. So they are basically wanting us to calculate the distance between the ships. So they want to know what is this distance right here, okay? Well, we're going to say this is the distance for ship 1, and then we also have the distance for ship 2. Okay, so we're going to say that's all of this. That's distance for ship 2. So the distance between the ships would just be the distance for ship 2 minus the distance for ship 1. So basically, you're going to be setting up 2 right triangles, 2 trig functions, and then we're going to go from there. Okay? Once we know our distances, we can subtract them, and then we'll be good to go. We'll have our answer. Okay? So let's see, what is our first distance? And I will do that in green. So we'll do this D2 first. So if I look at D2 and I look at the 265 meter height, I hope you're seeing this is again a tangent ratio, because we have, with respect to the 25 degree angle, we have a opposite side of 265 meters and an adjacent side of D2. So I have lost, there it goes. So we want to say the tangent of 25 degrees is equal to 265 divided by what? D2? And if I put that over 1, then I get D2 times tangent of 25 degrees is equal to 265. And then we're going to divide out tangent of 25. And that means our D2 is equal to what? So let's do that calculation real quick. Wow. All right. I've got to unlock my phone first, sorry. So we want to say 265 divided by 25 tan is equal to, and I get 568. And I've lost my mouse again, so this is 568.3, and this is in meters, okay? So now we want to set up the other ship. So it's going to be set up similar, but this one we're going to have tangent of 35 degrees is equal to 265. How did I do that? Oh my gosh, I didn't know I could do that. Well, there you go. No, there's a button on my stylus, but it actually works on this software and converts it to an eraser. That's kind of nice to know. So 265 meters divided by d sub 1. And I hope you're seeing this, the same setup. So I know what's going to happen here. I know my d sub 1 is going to be 265 divided by tangent of 35. So I need d sub 1. Okay? So once you're logged back into your phone, and clear that out. Now we get 265 divided by 35 tan, or tangent 35. Then that tells me that this measure is 378.5 meters. Okay? So now all we have to do is subtract these two. Now the distance between the ships, which we'll call D, is just D2 minus D1. So my distance D is equal to 568.3 minus 378.5. And that is going to be in meters. But now we just calculate. Oh. Get some notifications here, and it's messing me up. I need my calculator. Thank you. All right, so we got 568.3 minus 378.5. And that is equal to 189.8. So these are 189.8 meters apart. Okay? And we'll box in our answer. So again, this problem initially looks a little more complicated, but it's really not. If you'll draw your diagram, label everything, look at what you're asked to find, it's pretty easy to realize that you're dealing with two right triangles right here, and that if I find the base distances of those triangles and subtract them, that gives me the distance between the ships. But can I see that without doing a diagram? No. No, I would sit there and stare at that problem forever and never solve it until I draw it out first. Okay? All right, this is a cliff problem. It says from the top of a vertical cliff. Okay, so we're going to try and draw our vertical cliff. Let's see. We'll make it a different color. So we're going to draw our cliff, a vertical cliff, and then we have some ground here. So from the top of a vertical cliff that is 40 meters high, so this right here is going to be 40. Man, oh man, oh man. Might use that eraser. Of course, I just erased part of what I wanted. Yay. It's okay though, guys. We will survive. I'll make it a little jagged cliff here. Okay. So anyways, this is 40 meters high. So we're going to write our 40 meters here. And the angle of depression of an object that is level with the base of the cliff is 34 degrees. Okay? So we know we're measuring, again, from a horizontal at the top of the cliff. And we know we're looking at an angle of depression, so we're going to draw that. To some object down here. We don't even know what this object is. Okay, we'll just say it's some pile of sticks down here. Okay, maybe it's some freaky sculpture or something. Who knows? But we're going to draw this from here down to our object. It says that the angle of depression is 34 degrees. Okay, so this is 34 degrees. Again, that's measured from the horizontal. And they want to know how far is the object from the base of the cliff, which would be this distance D. And again, we have a right triangle formed here. And I hope you're thinking again, parallel lines, alternate interior angles, because this 34 degree angle of depression is the same as me looking from the object down below at an angle of elevation to the top of the cliff. That is the same degree measure, 34 degrees. Okay? So now we have our right triangle with an angle measure. And I hope you're seeing that once again, this is the opposite side and this is the adjacent side, okay, to that 34 degree angle. So we know we're dealing with a trig ratio here. So we're going to say the tangent of 34 degrees is the opposite side over the adjacent side, which is 40 meters is our opposite side, divided by D, our adjacent side. We're going to put that trig ratio over 1, and we're going to cross multiply. So we get D times tangent of 34 degrees is equal to 1 times 40 meters. And I can divide out the tangent function, tangent of 34. Again, you're dividing by tangent 34, but you have to remember that is just a number, okay? So tangent 34 divided by tangent 34 is just 1 times D is D. And if we do our calculation on our calculator, pull that back up, then we have 40 meters divided by tangent of 34. So 34 tan is equal to, and I get 59.3. Okay, so this is 59.3 meters, which tells me that the object we were interested in is 59.3 meters from the base of that cliff. Okay, and then you're done. All right, so let's move on. Here's another airplane problem. I think this is our last problem, but this says an airplane takes off 200 yards in front of a 60-foot building. So let's draw this out. We have a runway here. Okay, so we have this runway, and we have a 60-foot building. So we're going to draw our building here. And we're going to draw our little doors. And draw our little windows. Gotta enjoy. So we have a building. We're told this is 60 foot, okay, in height. By the way, 60 foot, if you have 10-foot floors, that's roughly 6 stories tall. So at what angle of elevation must the plane take off in order to avoid crashing into the building? Okay. So basically, we have an airplane over here. It's about to take off. So let's draw our airplane. Little wheels, and you have an airplane here. Okay. And it is about to lift off, guys. And it needs to fly at what angle of elevation? Okay, so we're going to say the minimum angle of elevation would be to the top of the building. Okay, all right, now obviously it would need to be above that to miss the building, but just for sake of the problem, we're going to say the absolute lowest angle of elevation would be measured to the top of the building. Okay, so we don't know exactly what this angle is. So we're going to call this theta. Theta is a typical angle measure. It's a Greek letter, but that's typically used for an angle measure. And we're told this is 200 yards. By the way, are y'all noticing something strange about this problem? You have 200 yards and yet a 60-foot building. We cannot work this problem until our units are consistent. So in this case, I would convert my yards to feet, realizing that 1 yard is equal to 3 feet. So if I have 200 yards, I'm going to multiply by 3 to get the number of feet, which will give me 600 feet. Okay? So, what trig function are we going to use to calculate this angle? Well, that's going to be our tangent, because once again, we're given the opposite side and the adjacent side. We're not looking at the hypotenuse, because our right angle is right here, and the hypotenuse is over here, but that is not what we're after. This is the opposite side. This is my adjacent side. So it has to be the tangent function. Tangent of theta, I don't know what theta is yet, is equal to 60 foot. That is my height of the building, and my adjacent side is how far the plane is from the building taken off. That's 600 feet. Now notice the feet units cancel. Okay, you have to have a unitless number for your trig ratio, which means your units are consistent. They're going to cancel each other. And I also have my zeros cancel, my n zeros, and I have 6 over 60, which is just 1 over 10 is tan theta. So theta is just going to be the inverse trig function of 1 over 10. Okay? So again, that should be on your calculator on your phone also if you want to use that. Or you could also get on Desmos graphing calculator and do the calculation there like we did last time. So anyways, let's try this out. We're going to do 1/10. So 1 divided by 10 equals as 0.1. And now I want to take the inverse trig function. On your calculator on your phone, you see sine, cosine, and tangent, but you don't see the inverse trig functions. Do not use the sine h, cosine h, or tan h. Those are hyperbolic sine, hyperbolic cosine, and hyperbolic tangent. Totally different function. But you'll see in the upper left, right above the left parentheses, you'll see a second button. If you hit second, and then you'll see the sine -1, cosine -1, tan -1 pop up. We're going to hit the tan -1, and I end up with 5.71 degrees. Okay? Because again, I'm still in degree mode. If you're not in degree mode, you're going to get a freaky answer. But this is 5.71 degrees. Which tells me this airplane taking off at that distance from the building would have to take off at an angle greater than 5.71 degrees. Okay? And that is our problem. And you're done. So in summary, guys, I do want you to read over these steps. Remember to always draw a diagram. There's not a single problem we worked on this lesson that I did not draw a diagram first. Make sure you label your sides and angles, whatever the given information is, label that on your drawing. Then I want you to look at the drawing, identify which sides are given. Is it opposite, adjacent, hypotenuse, whatever? What angle is given, if any? The last problem didn't have an angle. We ended up using the inverse trig function. But identify the correct trig ratio, set it up, and then solve. Okay? But if you can copy these steps into your notes and just refer to them as you do your assignment, I think it'll help you a lot. So I hope you guys have every success on your assignment. I hope you enjoyed the lesson, and I will talk to you next time. Thanks.